Pre-algebra lesson 84, formats for the addition rule, negative coefficients, and properties of equality. So let's start with properties of equality, because that's going to be the main focus on this lesson, and it's pretty much different rules of math that we use to solve equations. And I've got my own versions of the rules, but we'll go over that in a moment. Okay, so let's start with the properties of equality. So these are the main mathematical properties that everyone uses, and they're the addition property, or sometimes it's called the addition axiom, and you can substitute the word axiom for all of these. But the addition property says that if A equals B, then A plus C equals B plus C, right? And then there's the subtraction property, which means that if A equals B, then A minus C equals B minus C. Then we have the multiplication property, which means that if A equals B, then A times C equals B times C. And the division property, which says that if A equals B, then A divided by C equals B divided by C, as long as C does not equal 0. Now, if you are a very normal junior hire, you did not understand anything I just said. So let's use some numbers to explain it, right? Now, in a lot of math textbooks, well, just not all of them, they explain these mathematical truths using letters, right? The concept behind that is that letters are like variables, and any real number can be put in place of any of those letters. Now, that doesn't really sit well for most junior hires as we're trying to learn these really hard logical concepts, so let's just explain it with actual numbers, because that's what your arithmetic brain is used to seeing and likes a lot better. So we'll do something simple. We'll do the number 2. And that's going to equal the number, we'll do 6/3, right? This is true. We can see 6 divided by 3 is 2, or 6/3 reduces to the number 2. This is a true equation. I've got the same number written different ways, so we're going to test all of these axioms so that way you can see them. We'll start with the addition axiom. Now, the addition axiom says that if these two numbers are equal, or if I have an equation as signified by this equal sign, I can add the same number to both sides and still get the same answer. So let's add a simple number, like we'll add 1, right? So we'll add 1. So the left side, I'll put a little dotted line. The left side is pretty easy. If I do 2 plus 1, I end up with 3, right? And let's see here, 6 over 3 plus 1. Well, I have to rewrite 1 as 3 over 3. 6 over 3 plus 3 over 3 is going to give me 9 over 3, right? And 9 over 3, we can see, still reduces to the number 3. Cool. Hey, that works. Now, does it have to be the number 1? No, I can add whatever number I want any single time, and the equation will still be equal. Will it be the same numbers? No. The numbers will change, but the main thing that matters is whether or not this equal sign in the middle is still true. So that's the main thing we're testing every time we change the equation. We need to make sure that the equation is still true, meaning that the side on the left is still equal to the side on the right, or the amount. Okay, now let's use the subtraction axiom. Okay, so using that same logic, I can say, hey, if I can add anything to each side and still have the same number, I should be able to subtract. Okay, so let's subtract an easy number. We'll subtract 2. Okay, so I'll subtract 2 from each side of the equation. Keep this dotted line going. Notice I put a dotted line down the middle. That helps me understand the left and right sides of the equation, right? Because the equal sign is the middle of the equation every single time. Okay, so you find the middle by putting a little dotted line on the equal side, and you've got your left and right sides. So left side, 3 minus 2, that's easy, that's 1, and 1 should equal whatever 9 over 3 minus 2 is. Well, I have to rewrite negative 2 as a fraction, so that's going to be negative 2 over 1, then I need a common denominator of 3, so then times 3 times 3, 2 times 3 gives me 6 over 3, so now I do 9 over 3 minus 6 over 3, which is going to give me 3 over 3. 3 over 3 is still 1. Great. I haven't broken any rules yet. Now, let's go to our multiplication and division rules. So, the multiplication and division rules say that if I multiply a number by each side of the equation, I should still have the same number, right? So, let's do this. Let's multiply by 3. So, I'll do 3 times 1, and I'll do 3 times 3 over 3. Now, what happens here is 3 times 1 just gives me the number 3. And then 3 times 3, I gotta put that over 1. 3 times 3 gives me 9. 3 times 1 gives me 3. So 3 equals 9 over 3, which is still true, right? I've still got some mathematical truth here. So 9 over 3 equals 3. That's great. Now let's do the last one, which is the division axiom. Okay. So the way the division axiom works is that if I divide one side by a number, then I can divide the other side by that number. So let's divide each side by 3. We'll use a fraction. So if I do 3 divided by 3, well, that's just equal to the number 1. Now over here, since this is already a fraction, I'll divide like this, and then to divide I have to invert and multiply. So that becomes 9 over 3 times 1 over 3. 9 times 1 is 9, 3 times 3 is 9, 9 over 9 is equal to 1, and it works. So here we see the addition, subtraction, multiplication, and division axioms. Now, the way that I break these down into solving equations is with 3 simple rules. So we're going to use those mathematical truths and 3 simple rules to solve all of our equations. Remember, the goal of an equation is to get the letter or the variable all by itself on one side of the equation. And to accomplish that, we are going to first use PEMDAS backwards. So we use PEMDAS backwards to move numbers, and I'll explain what that means in a second. 2 is we are going to use the opposite action to move numbers. And the third rule is equivalent exchange, which means if I do something to one side of the problem, I must do it to the other, so that way it remains an equal an equation, right? And equivalent exchange is more or less what you see in all 4 of these rules. Now, let's do an example problem, use these 3 rules, and solve it. So let's say we have something like, let's say we've got negative 3x plus 4 equals 10, okay? Now, remember, the goal is I want this x all by itself. There's 2 numbers next to x right now, negative 3 and 4. Let's go to rule number 1. I'm going to use PEMDAS backwards. So if I'm using PEMDAS backwards, I need to start with addition and subtraction. If I'm starting with addition and subtraction, that means I'm going to start with the plus 4. I'm not using the negative 3 because this isn't a minus 3. This is negative 3 times x. This is actually multiplication in disguise. It looks like a subtraction, but it's actually multiplication. This is addition and subtraction, so I'm going to move the negative 4. Now, the way I'm going to move the negative 4 is by using rule number 2, which is to use the opposite action. The opposite action of positive 4 is subtract 4, and then rule 3, equivalent exchange. If I do something to one side of the equation, I must do it to the other. I find the left and right sides by drawing the dashed line on the equal sign, and now I rewrite the equation. Well, negative 3x is still going to be negative 3x. Positive 4 and negative 4 cancel, and 10 minus 4 is now 6, positive 6. Great. Now, I'm not done. X is not by itself. So I go through the 3 steps again until x is all by itself. There's no more addition and subtraction, there's only multiplication. So now I'm going to divide by negative 3. Here, the negatives cancel, the 3's cancel, and that's the opposite action of multiplication is division. Now I'm going to use equivalent exchange. If I divided that side, I have to divide this side. Now I've got 6 divided by negative 3, which is positive divided by negative, which equals negative 2. So my final answer is going to be x equals negative 2. All right, this has been a pretty long video, so if you think you've got the concept and you want to go on to your lesson, I'll do one more example just in case some of you are still having a little bit of trouble. All right, so last example will be right here. And let's do one with fractions, because that can be difficult sometimes. So let's see here. We got negative 3 times x plus 1/2 equals 3/8. All right, so again, goal to get letter x all by itself. I'm going to use PEMDAS backwards, which means I'm going to move the addition first. I move the addition by using the opposite action of subtraction. So opposite action, I minus 1/2 from each side of the equation. I find the middle of the equation by drawing a dotted line on the equal sign. And then I'm going to do equivalent exchange, so minus 1/2. What happens over here? Negative 3x just drops down. The negative and the positive cancel. And now I have to add fractions. Okay, so I need this to have a denominator of 8. So multiply by 4 over 4. That gives me negative 4 over 8. So 3/8 minus negative 4/8, that's going to give me negative 1/8. Right, so now I've got negative 3x equals negative 1/8. So now I have to divide. Whoops, wrong color. Now I divide by negative 3. The negatives cancel, the 3's cancel. And then over here, since I've already got a fraction, I'm going to divide like this. So I divide by negative 3 over 1. And then remember, we divide by inverting, multiplying the second number. So now I've got negative 8. Ooh, whoops. I almost did that wrong. I've got negative 1/8 times negative 1/3. So here I see 1 times 1 is 1, 8 times 3 is 24, and the two negatives make positive answers. So the answer is that x equals 1/24. Alright, sorry for the long video, but a lot of important concepts to cover. If you guys have any questions, let me know in class, or let me know online on the website, and I'll see you in class.